Hi everyone, in this video we are going to discuss climate models. And so if you get one thing from this video, I really hope it is that you understand that climate models are unbelievably difficult to predict. And essentially it comes down to the fact that there are four very challenging variables that you must consider. So let's go through these one by one. The first thing you would have to consider is your rate of economic growth. And so essentially you need to go through, and for every single country, you need to decide if they're going to have an increase or maybe a decrease in their economy and how that's going to affect their relation with their power supply. So are they going to invest into green technology? Are they going to start using more power plants or coal power plants? You need to look further into this. The second thing you need to look at is the rate of new green energy sources. And so this kind of has to do with the last one, like what we were talking about, but you essentially need to factor in whether or not the country is likely to develop green energy sources and whether or not they're actually going to use them. So if they start using something like solar power, in theory, their air pollutants or their greenhouse gas emissions would decline. And so you need to kind of factor that in. The third thing you need to talk about is how to assemble these positive and negative forcings. So the different factors that are going to either warm or cool your planet. And the last thing, which I think is hopefully the easiest now, but it was not something easy a long time ago, is that you need to decide whether or not you're going to consider natural or anthropogenic forcings. So you, as a scientist, need to decide whether or not you're going to factor in human forces or natural forces. You need to look at both of these. So let's do this together and consider what you would do if you were going to develop a climate model. And so this is the best graph to kind of help you answer that question. So let's look at the x-axis first. So this is our years. So we started around 1900 and we go all the way to 2000. And then our y-axis, we essentially are looking at our change in temperature in our unit degrees Celsius. And so let's get comfortable with this graph. So when we have our blue lines, that is the one that's considering natural forcings. The pink line, or reddish, it looks pink to me, is basically looking at your human forcings. Where the black line is your actual data. So the black line is a true depiction of the change in temperature in Celsius for your global, for your land, and for your ocean temperatures. So here is my question to you. Looking at this graph, I want you to interpret it. If you were to create a climate model, would you consider natural, anthropogenic, or both sources? Go. All right, did you get an answer? Hopefully you did, and the correct answer is that you should include both sources for sure. And so what we see is that the blue line is just incorporating natural sources, the black line is our actual data, and it definitely follows the pink line, which is the human sources or anthropogenic forcings. So our best model is going to incorporate both sources, okay? So now let's look at our four best climate models right now when they're overlapped over each other. So this is just a graph of our atmospheric carbon dioxide concentrations. So our y-axis is literally just mapping our carbon dioxide concentrations in unit of ppm or parts per million, where our x-axis is mapping our future years. And so what we can see here are four different lines. And so let's go through what each one of these is mapping. So our green line is our most modest line, and essentially that is a model that holds the carbon dioxide concentration constant for year 2000. So if we held all of our levels constant from the year 2000, this would be our estimated growth or our increase in our carbon dioxide concentration. Now our blue line is a little bit higher, and this one assumes that we have an increase of our population, our human population, of up to about 9 billion people in the entire world, but this is assuming that we are heavily investing into green energy sources, so renewable energy, so solar power, wind power, things like this. Our orange line, or orangey yellow, whatever color we want to say that, is that we have an increase in our population again up to 9 billion, but this is without embracing any of our green energy sources. So this is just what's going to happen if we have an increase in our human population, which is going to happen. And then our pink line is it saying that we have an increase in our human population greater than 9 billion, but this is with more so in resisting new energy sources. So new energy sources. So this would be the worst thing possible, where we rapidly increase our human population, but we don't really do anything to deal or to reduce our global greenhouse gas emissions. And so this is something that's really, really bad. But here's the thing we need to understand about these climate models, is that all four of them predict completely different carbon dioxide concentrations by the year 2100. They all very different. But the main thing, or I guess the bottom line, and this is the thing that our IPCC keeps coming back to, is that our bottom line is, regardless of your climate model, our carbon dioxide concentration is increasing, which means that we are definitely going to have some kind of global warming, and hopefully it's just not too drastic. So that's the bottom line. Climate models are unbelievably hard to predict, but they are all telling us the exact same thing, is that we are definitely experiencing an overall increase in our global temperature. Bye, guys.